science fans! Welcome back to Science Fun with Austin. Today's episode is a viewer request from Keith in Mississippi, who asked if we could come up with something to do with this. This is basically a flashlight with a little bit of a twist. So let's see what we can come up with. So if you've ever wondered how something like this works, essentially in the body of the flashlight we have a DC battery, a DC to AC converter, and then some step-up circuitry to boost the AC voltage high enough so that it will discharge across the gap. Good rule of thumb for air is that it takes 33,000 volts per centimeter to get a discharge. And you can see we're pretty close to a centimeter. So that figure's approximate depending on the shape of the electrode. So we probably have around 30,000 volts arcing across every time we do this. Alright, so the sheet of paper that came with this mentioned a few things not to shock. Among them were children and the elderly, and that did seem kind of mean. But it did say not to shock metal things, so that's something that they recommend not doing. Let's see what happens. So you could hear the sound change, and I think you could see the arc path change from going across the electrodes to going through the can and then back out of the can into the other electrode. When you have, basically the spark is just going across the path of least total resistance. In another variant on the metal theme, let's try putting a piece of tinfoil between the electrodes. I think with this it should basically act like the tinfoil's not even there. Actually, you can see that the outside rim of the flashlight is where the spark ends up going. So we do change the path. Interesting. Alright, for this test article, let's try some receipt paper. It's a resistor that's thermally sensitive, so we should be able to see if we're heating it up pretty well. And you can see it does a neat job of triggering the heat-sensitive dye there, so it's probably doing a pretty good job. Okay, there have been occasional stories claiming that alcohol-soaked persons who somehow ended up getting tasered, shocking that those two things would be correlated, burst into flames. So here we have a paper towel soaked in isopropyl alcohol to simulate booze-soaked clothing. Let's see if anything happens. Why, yes! That potentially could happen. Well, this electrical tape's rated for 600 volts. Let's see what happens if you put 30,000 through it. Definitely tell that it is providing some resistance. Well, unfortunately there's only one test article left, and it probably does go to show that I need to find myself a new hobby. Ow! Ow! Now, an issue there is that that kind of hurt, but it wasn't all that incapacitating, so you may want to choose an alternate self-defense weapon. Well, until next time, have fun, science fans!